However, when I just started thinking about becoming a software engineer, I started playing with my home lab. And while doing that, while setting things for my personal use, I realized that unless you are tech savvy, it is not that easy for you to have a secure and free way to have a shared clipboard between devices. And while personally for me I could easily use SSH, it's not easy for somebody else. So this is exactly why I created actually my first portfolio project, the Lan ClipBoard. So here's the basic idea. My home lab consists of 3 different devices running on different operating systems. And I want to have a shared clipboard between them. Initially, I was thinking, why not put it on a server and be done with it? Because that would be probably the most straightforward option. And that would work, but home labs are created for experimentations, and experiments can go dramatically wrong. Meaning that if something goes wrong, then the server goes down and the whole service goes down, which is not ideal. This is exactly the reason why I decided to go a different route, a decentralized option, which is running local instances of the Lan ClipBoard on different devices and them being synchronized between each other. So how does it work? Basically, the idea is that we copy something into our operating system clipboard. And the Lan ClipBoard from time to time pulls the data from that. Then as soon as it is done, as soon as the Lan ClipBoard pulls the data, then it starts broadcasting to other instances of the Lan ClipBoard. And then they are storing that in their internal storage, and then we can paste things wherever we need, either text editor or a folder. But the question is, how do we know where to send those entries? How do we know who are the peers to receive this broadcast? And there are 2 options. One of them is the most secure one and the most straightforward. Just have a prepared peer list and then send the data to them. But that is one option. And the question is, what do we do if the network is dynamic? In that case, it becomes a bit tedious to set up every time, which is exactly why we have another option, discovery. So how discovery works is that as soon as we are starting an instance of the Lan ClipBoard, it starts broadcasting to all devices on the network. Hey, here I am, and here's the service I'm providing. I have the Lan ClipBoard TCP local service. If you're interested, let's connect. If we have an instance of the Lan ClipBoard running on the same network, if we have another instance, then they can initiate the handshake. And if the handshake is successful, then we store the respective IP addresses in the peer list. Now let's dig into how discovery works. And before we go into the code itself, I need to emphasize that discovery usually follows the Multicast DNS protocol. And it is quite a complex topic. The good beginning would be the article on the Cisco website about basic theory behind mDNS. And I would highly suggest you do your own research even if you don't use this kind of system in your own work right now. Because again, you might end up in some Internet of Things project, and this is a must for this kind of work. And generally speaking, it is quite useful to understand the networking principles that are used across different software engineering domains. And the good news is that, like any other complex topic and any complex mechanism in programming or software engineering, there is a ready library that already has quite a few things implemented. And for Python, it's the zeroconf library. Quite a useful bit of code. But the basic is that zeroconf expects several methods to be implemented and for them to follow a certain path. The basic idea is that, well, the starting point of the zeroconf flow is the start method. Kind of self-explanatory. What happens here is that here we are configuring some properties for zeroconf to process properly. And also, quite important for us, the service info. This service info is being passed to all the devices on the network. And the important things for us is the service type. So as soon as this is being advertised for our devices on the network, we are also starting the async service browser. And what the async service browser does, it monitors the network for a specific service type. And as soon as this type is found, we are going to go into the add service method that this object is going to call. And after we do some configurations, some checks, we are going to call the handshake with peer method. And what it does basically is it simply calls the API that we have in the API module. And this handshake API call will pass some parameters that we are going to expect and gonna need for the implementation itself. So we are passing the device ID, device name, the platform this device represents, the protocol version, and whether we support text or files, or files, and whether we support encryption. Because, yeah, this application supports encryption because, again, if we are doing this for serious work, we don't want a malicious actor to intercept our messages or our texts or files what we are passing. And what happens inside the API module itself is that we extract the body, and after we check whether the body parameters are exactly what we are expecting, and if this is registered in our registry. If we don't have this in a registry, then we add this reference to the device that advertised the service. Now that we are done with that and have a peer list, we can go and look into the clipboard listener. So what it does, it just simply monitors the clipboard for the new entries. And what we are doing here is we have this abstract clipboard. I'll go back into this a bit later. And it calls its getClipboardEntry method to check the latest entry. This is done on a set interval, so after a set period of time, it repeats the same request. Next, we are checking that we saw this or not. And if we saw this an entry before, we ignore it. If not, we are checking also that this is stored in our local clipboard storage or not. If it is not stored there, so this is indeed a unique entry, then we are safely sure that we can store this in our internal clipboard storage and then broadcast it to our peers. And what happens here is that we are trying to encrypt the body, and we are encrypting the body if we have the public key, because we are using asynchronous encryption for our texts. And after this is done, we go to we're calling the clipboard API or clipboard entry API call that is going to call the post clipboard entry on our peers endpoint, and here we are decrypting the body. And as soon as the body is decrypted, again, if the private key is saved, as soon as this is decrypted, we are storing this in the clipboard storage that's on our peer's device. After this is done, we can paste it in our target. But before we go into how we paste things, it's important for us to review the clipboard storage itself, or rather the clipboard implementations, because surprisingly or not, each operating system has its own clipboard implementation. And initially I was expecting something like Windows having its own implementation and Mac and Linux having something similar. Well, I was extremely surprised to find out that in fact Windows, Linux, and Mac have a complete different implementation. So how do we find which implementation we should use? Or rather, how does the Lan ClipBoard know which implementation should it call? Simply put, we have the clipboard factory that checks what platform we are running on, or rather what platform is the instance running on. So if the platform is Darwin, which is the core of macOS, Darwin is a BSD-based operating system, and if we are running on Darwin, we are returning the Mac clipboard. If it's Windows clipboard, and on Linux it's a bit more complicated, but we'll go to that in a moment. So why there is no single implementation for the Linux clipboard, you might ask? Well, surprisingly, Linux does not have a default clipboard. As a matter of fact, the clipboard is part of the graphical user interface engine. And on Linux, there are two different engines, Wayland and X11. And when we go to the clipboard, get Linux clipboard, we are checking the XDG session type, and based on that, we are either loading the Wayland one or the X11 clipboard. They're pretty much similar from the logic perspective of how the clipboard implementation is done. In simple terms, we just call some terminal commands, and that's it. So the implementation, well, it might look a bit complex, but it doesn't do anything except just call the appropriate Linux, the appropriate shell command. For Linux, we need to call, for Wayland, we need to call WL paste or Wayland paste just to copy that, the entry that's in the clipboard. And to paste something new, we first need to call the Wayland copy and then trigger the copy mechanism, the pasting mechanism on the system. On Mac, it was pretty much even more straightforward. As a matter of fact, it was surprisingly easy to implement. You just call the AppKit libraries that are provided by Apple. And on Windows, it was extremely complicated. It turned out, and I found it the hard way, that Windows uses that the Windows clipboard is a separate service that needs to be stopped before you access the clipboard itself. So to read from the clipboard, you stop the service, read from it, and then you start it back. And if you don't start it back, then you are basically blocked and you cannot copy and paste anything from that. Now that we are done with operating system specific clipboard implementations, it's time to talk about very shortly about the clipboard storage. And we'll start with the specific data that we are storing, because again, given that each implementation, each operating system has its own specific implementation of the clipboard, it would not be feasible to store them the same way. So instead we have some middle ground, and in our case we are storing some additional data as well. So first of all, we are storing the origin, meaning the device that it came from, the platform, the platform that this originated from also, the type of entry that we are storing, the entry itself, and the timestamp that is then used to check if it is the latest entry or not. Specifically about the entry, I need to mention that when we are copying text, it's quite simple. We store the text in its raw form. When we are copying files, we are storing the file paths on the source of those files. So basically, if the file is located in your documents, we store the path to the documents and the file itself, the full path. And then we use that to pull the files itself. But how do we know how to paste things? How do we know that how does the Lan ClipBoard know that it needs to paste something? Well, for that we have the keyboard listener, and the basic idea here is that we have a shortcut that is configurable, and what the keyboard listener does, it monitors all the keyboard, and as soon as any key is pressed, it adds that key to the pressed set. On release, it deletes that key, obviously. So the idea is this, that as soon as the set contains all the paste hotkeys, meaning for Mac by default Command-Shift-V, for Windows Ctrl-Shift-V, then we are calling the trigger hotkey match, which then on its turn puts the latest entry in the paste queue. And some of you might ask, why do we need a paste queue? Wouldn't it make more sense just to paste it right away? And the idea is this. Unfortunately, if we are supporting files, if we are supporting file transfer, it takes some time to paste those files. And for the application to be thread safe, it is much safer, it is much more logical for us to have a paste queue. From my personal experience, if a machine is fast enough, you would not even notice that the paste queue is actually there. So it is emptied before it is before you are done with pasting everything or anything. But it is still there just in case we have a big amount of data. So what happens in the paste queue is that when we put something in the paste queue, we are the paste queue then is monitored by the paste queue handler, and as soon as something enters that, the handler just checks first checks the type of data we've pasted in the queue, whether it is text or files. If it is a text, we simply put we simply call the clipboard implementation of that is of our target device, and call its paste clipboard entry method. Well, for the file transfer, it is a bit more complicated. So what here first we are doing is we are extracting the list of directories where the files are stored on the source machine. So let's say we are copying from a Windows laptop to a Mac laptop. So we are storing paths on the Windows laptop in this list. So as soon as we've extracted this list and prepared it to be passed then to the next method, we are passing it to the API module getFiles method. And what we are passing to the getFiles method is we pass the list of those files, the origin of the files, meaning the IP address of the target machine, of the source machine, the public key, private key, and key paths if they are configured, if security is enabled, and that's that. And after this is done, after we've if we go to the getFiles method, you can see the basic endpoint what we are using to request those files, and what we are doing is that we get the list of paths that we are requesting, and for each path in that list we are requesting files one by one to be downloaded to a temporary folder. Then this temporary folder is if the file is encrypted, then we decrypt it, and we paste already the decrypted file in our target folder. Now it's time for a quick demonstration of how this works. So specifically for this, I added a temporary log in the API module inside the try-decrypt body method, so that it ensures that if the security is enabled, then you will see that the payload is indeed encrypted. And to demonstrate that it works, it's not enough to show just one screen. You would need to see another screen, which is exactly why I am sharing my screen from another device, from my Windows home lab device. and both the Mac and the Windows device are temporarily on the same network. So here is what I will be doing. So to demonstrate that that the system works, first I will have to start it. There are two options to start the application. One would be going to the terminal and going something like Python and config UiPy. And here it is in its full glory. Next, we should start it on the Mac as well, and I'll be starting it from from PyCharm, and here it is as well. So right now we already see that we have identified our IP addresses. For Windows, as you can see, or as I hope you can see, it's 192.168.0.7, and for Mac it's 192.168.0.72. So it's on the same network, which is lovely. Now we start the applications on both devices, and here we go. Let's quickly walk through the logs. As you can see that we are starting with a local ID Darwin at our IP address, and we have several logs showing that here we are. We can see that the handshake request has indeed passed. All good. And we have discovered, because we have discovered the other device, which is of type Lan ClipBoard.tcp.local. As you can see, mDNS discovery works fine. Now let's open the text editor, and we have this super awesome text called test. We'll copy it from our Windows device, and let's attempt to paste it on our Mac. We'll press Command-Shift-V, and here we are. We see test. Awesome. And also in the logs, you will be able to see that when we copied something, our Mac received a post request from our Windows device, and we responded with 200, meaning that the request was successful, and we attempted to paste test, and we were successful at pasting this text. Now let's go and test the other way around, and let's have it test2. Let's copy this. As you can see, we've sent the broadcast to the Windows device and received 200. OK. Let's go to the next line on our Windows device and press Ctrl-Shift-V. Oh no, we see that only the old text is here. Why is that? Well, the thing is that by default it is configured to be, well, Command-Shift-V, because this was initially implemented for my Mac. So to change this, we need to stop our Windows instance, go to our hotkeys and press reset to default, and you can see we have Ctrl-Shift-V now. We save, and we need to start the application again. Here we go. And given that right now in our memory of our Windows device we have nothing, we need to copy a new text. So let's put the text free. Let's copy it, and we now can press Ctrl-Shift-V, and here we go, test free. This test is successful. Let's save this and let's close this, and let's also go to our folder. So this is the text we were editing. Let's copy it, and let's also open a folder in our on our Mac. And now let's copy our secret our new text, and let's paste it in our test folder. Here we go. As you can see, we have test and test free. All is good. And now let's do something crazy. Copy 2 files from the test folder to the new folder on our Windows device. And here we go. Some time passed, but we successfully pasted those 2 texts. Awesome, right? Now, what about security? When we were configuring things, we did not put anything inside the in our security tab. So luckily, we can easily generate a new key. Let's call it super secret key. One. And put a password, which is not QWERTY, definitely not QWERTY, and press the generate button. Congratulations, configuration saved to config/config YAML, yay, and generated and packaged key pair. So basically what this means, that we all have generated a new key pair and archived that. In reality, this is just a zip file, but I decided to use the .ska extension just for fun. Now, given that we are still running our instance and the whole application did not apply any security yet, for that we need to restart the application. Now we can go to the Explorer and copy our super secret key, and let's paste it in our test folder. Bam, here we go. Now what we need to do is open our configuration again, stop the instances on both sides so that they don't waste any resources. And let's go to the security tabs on both applications, on both instances. So the first thing we need to do is press the enable security flag. Browse and select the appropriate key and pass and put in the password, which I again to demonstrate, let's say we are putting a wrong password. Import key, fail to import. Lovely, means we need definitely to use the correct password, which is definitely not QWERTY. Congratulations, it's saved. And just for good measure, let's save our configuration. Let's go back to the General tab and let's do the same on our Windows device. And as you can see, we already have the path. And let's also add the password. We import the key. Key was activated. Save. Great. Now let's we go and start the applications again, starting here and starting here. Now, let's go and do some secret stuff. We'll go to our new folder on our Windows device and copy some super secret text that nobody needs to see. But you will not tell to anybody, guys. I believe you. And let's paste it. Here we go. Yay. Now, how do we see that things are indeed secure, that the payload indeed came secure? Well, let's go back to the log, the place where I've put the log. Let's open the execution and let's see the decrypting log, and you can see the encrypted JWT, and it is indeed quite a big text. Yes, one might think, hey, but this is just a JSON web token. Well, it's partially true. Let me show you actually what it is. So, JWT decoder, there is such a tool online that you can use to see what is inside a JSON web token. You can get the text and paste it here. And here you can see that this tool only supports JWT, that uses GWS compact serialization, which actually in reality means that this is indeed not a JSON web token. Awesome. Now let's check that it works both ways. Let's add that this is from Mac, and let's copy this and let's go here, and we shall paste it, and we can see that the message from Mac did come through and was indeed decrypted and worked fine. Now, how about we do a test? What about the files? And for this, the easiest thing to do would be, let us copy everything from this folder, and let's go to our test folder, create a new one. It's an untitled folder, and we will paste it here. And let's wait for a bit. Here we go. All the files are now here present. And basically, that's it for our demonstration. And if you're interested in this kind of content, feel free to stick around. And if you have some feedback, I am looking forward to reading that in the comment section below. Thank you and bye.